Hey guys, so in this video I'm going to give you a quickish review of the main types of factoring. So we will review 4 types of factoring: the greatest common factor, grouping, trinomials, and sum and difference of cubes. So just to be clear, the purpose of this video is to help you determine where you are rusty and maybe where you might want to get a little bit more practice. So this video is really just a brush up. I can't do a quick review and go through every type of trick. So I will kind of give you just a crash course reminder. And then if you need more examples, don't worry. I have another video where I've compiled all different types of examples, and I have lots of lesson videos that you can check out as well. So all of that's going to be in the description of this video. So the first type of factoring that always comes up is the greatest common factor, and I think the easiest way to explain this is with this example. So I've got 3x plus 3y. So the question here is, what do these two terms have in common? And so that, I think that's pretty clear, right? So they both have a 3. And that 3 is what we would call the greatest common factor, or the GCF. And so what we're going to do then is we identify that each term has that 3, so we're going to factor that out, i.e. we're going to divide it out. So notice I put that 3 in front, and then if I divide that out of these two terms, what am I left with? X plus y. So now we've got the basic idea, and I want to go through a couple of examples related to this that are a little bit more tricky. So starting with A here, so I've got 15x squared y plus 10xy cubed. Now you might want to pause the video here to maybe give all 3 of these a try if you are trying to review this. So what I notice in A is that 5 divides both of the numbers. And then notice that for each term, now in this case they both have an x and a y. So what you're looking for then is, what is that lowest term that divides both? And in this case, this idea of lowest means that we look for the smallest exponent. So as I look through this, the smallest exponents between the x's would be right here, just a plain old x. And then here's the smallest exponents of the y. So I'm going to factor out 5xy. And if I factor that out, so now I really use properties of exponents to help me finish this. So 15 divided by 5 is 3. And then when I divide out x squared y, so the y's would cancel out, but I would still be left with one factor of x. So you might have to stop and think about that for a second. So I had x squared y, I'm dividing out xy, so in this case I'm just going to be left with x. And then for the other term, this will be plus 2y squared. And so there is it in its factored form. Okay, so starting with going on to B, I guess. So again, consider pausing and trying these. So now I notice that 9 divides the 3 numbers. So I will factor out a 9. Now I have to be careful here. So this is xy to the 4th, x squared z, and then x to the 4th, y to the 3rd. So y and z do not appear in all of the terms. Only the x part does. So I cannot factor out the y or the z. So it's got to be in all terms for it to be greatest common factor. So then as I look across all of these terms, what's my lowest power of x? It's this one right here. So I'm just going to factor out 9x, and then I'm left with 3y to the 4th minus 2. So I'm still going to be left with 1x and then the z, and then plus 9x cubed y to the 3rd. And so there you go. And now moving on to C here. So as I look at this and I just rack my brain for what divides into this, nothing. So you're not guaranteed to have a GCF. So you always want to stay on your toes and think about what makes sense. So in this case, we would just call this prime, and that's it. That's the term. Now, any expression can have a GCF, so you always want to watch out for it. It doesn't have to just be a problem like this. It can pop up in any type of factoring. Okay, so now I want to move on to grouping. So grouping usually has like 4 terms. And so I'll show you kind of the classic example that comes up with grouping. So I've got ax plus ay plus bx plus by. So what I want you to notice is that there is no GCF. There's no one term that divides into everything, okay? But what you might notice about this is that the first 2 terms both have that a in common, and the second 2 terms have that b in common. And that's kind of like the classic sign for grouping. So what we're going to do then is out of each pair, we're going to factor out those variables. So we're going to factor the a out of the first two terms, and if I factor that out, I'm left with x plus y. And then we're going to factor the b out of the second two terms, and once again, I'm left with the x plus y. So the thing about grouping is then you want to check that those two things in the parentheses are the same. And if they're the same, then basically what you can do is you could just take the stuff that's in front of the parentheses and check this out. So now it's going to be this a plus b, so that's what goes here, and then the x plus y. Now you could flip-flop these if you want to have x plus y times a plus b, that's totally fine. But this will be how that factors. Okay, so again, we're just doing a really quick review here. So I have just two examples here to kind of run you through this. So I will run you through these, and then if you are looking for like a longer explanation of this, by the way, I have other videos where I do that, so do not fret if you're like, oh, I need way more explanation. No problem, I've got you. But to go through this, so I'm kind of following that mentality. So out of the first two terms, what do we have in common? Well, it would be a 3. So if I factor out 3, that's going to leave me with x plus 2y. And then out of the second two terms, what do they have in common? They both have a y in common. And notice that these are both negative, so I'm actually going to write this as minus y. And so then that's going to be left with x plus 2y. There's what I'm left with. And so now, notice what's inside the parentheses. It's the same and it's the same. So this will factor as 3 minus y and x plus 2y. Okay. And then in the next expression, so I've got x to the fourth minus x squared minus 3x cubed minus 3x. Okay, now take a moment to pause here and notice there actually is a GCF here, right? So all of these terms have an x in them. I can factor out the x. This will be x cubed minus x minus 3x squared minus 3. Now I can press forward with factoring this out. Okay, so if I do that, then in the first two terms, so let's see, out of these two terms, I can factor an x out. So let me use a square bracket, and then if I factor that x out, that's going to leave me with x squared minus 1. And then out of the second two terms, so then what's that going to leave me with? Minus 3, and that's going to leave me with x squared. Now be careful with this, plus 1. So now we have a problem. So this is x squared minus 1, x squared plus 1. So this, we can't go any farther with this. These are not the same thing in the parentheses, but I will show you a second trick that you can try if this happens to you. So let's go back to this line here. So let me clear some space. Okay, so if your grouping doesn't work, what you can do is you can switch the order of your terms and see if that helps. So what I mean is I could rewrite this as x cubed minus 3x squared and then minus x minus 3. Now sometimes this will work and sometimes it won't. So if I try to finish this, so let me replace this line now with what I just rewrote this as. So give me a second. Okay, so now and how this is set up. So notice in these two terms, I can factor out an x squared. So factor out x squared, and then this is x minus 3. And then out of the second two terms, I can factor out, well, I really can't factor anything out except for like the minus sign. So I'll just write that as a minus 1. So notice what happens, the symbols flip. So we still have the same problem, right? So we actually still can't do this one. So for this one, the best I can really do for factoring is this. So the reason that I put this one in here was one, to show you this trick of flipping things around. I do have videos where this trick does work out, so I just wanted to kind of show you that there's like more than one way to kind of tackle something. But also just to kind of once again warn you to not be in that computer mode where it's like, oh, I see 4 terms, so I'm going to just group it. So this right here, this would be the answer. So this part here, maybe I'll just cross it out. That will not work. We can't really factor this any farther. Now, like I said, there are some other cases of grouping, but that's really the gist of it. So I've kind of given you the high level notes. So be sure to check out some of the other videos that are in the description if you'd like this at just kind of a more in-depth pace. Okay, trinomials. So trinomials have three terms, and a lot of times we think of them as like ax squared plus bx plus c. So we think of it as this thing with an x squared term and an x. However, I will also say that you could have more variables, so you could have something like ax squared plus bxy plus cy squared. So i.e. you could have an x and a y in your trinomials, and I will show you that. So I recommend with trinomials that you use the trial and error method. So if you look on YouTube or you look in any math book, you can find all these different methods. But the thing is, like the trial and error method, it probably takes the longest to learn in some ways, but it's actually the quickest to use, and it will make you the most confident if you can kind of get there. So that's what I'm going to use in this video. And if you're one of my students, then you definitely want to use the trial and error method, because if you're in like my intermediate algebra class, you just don't want to be bogged down with having to use an algorithm every single time. It's much quicker to use trial and error. Okay, so I have a couple of examples to run through with you guys on this, just to kind of give you the high level principle. So the idea behind the trial and error method is that you know that you're going to set up this thing as a factorization of two terms, and all you really care about is the first term and the last term. And you just write something down and see if that gives you the middle term. It's really that simple. And so like I said, it takes a little bit longer to use, but there are some tricks to this. So I'm going to try to also run through those tricks. So whenever you see x squared in a trinomial, you know that the way to set that up is going to be x times x, okay? So x times x gives you x squared. And then what do you multiply to get to 2? Well, there's only one way in this case to multiply to 2. So that would be by using 2 and 1. Now, the other thing to notice with this, 2 plus 1 makes 3. That trick works as long as this is just x squared. That trick doesn't work quite as well if this does not just say x squared, and I'll show you an example of that in just a couple of minutes here. Okay, so the thing about trial and error is you want to go back and multiply this. So notice here I take the x times the x and I see that I get the x squared. I take the 2 times the 1 and I see that I get the 2. So then really the only other things I have to do are 2 times x, so that's giving me 2x, and then x times 1, that gives me just x. So that's going to give me the 3x in the middle. So the thing about trial and error is that you want to be able to kind of check this in your head. So if you're not there yet, don't worry. I will kind of give you just some hints on it, and I'll continue to show you the breakdown of how to multiply things together. Some of it's just kind of looking at this in the right way. If you're really not sure when you're working with something, you can always just take a moment to multiply this whole thing back together. So this would be x times x is x squared, 2 times x is 2x, 1 times x is x, and 1 times 2 is 2, and then I see I get x squared plus 3x plus 2. So you can always just take a second to multiply this back out and see if you get this, and then you'll be good to go. Now, with b here, with b, now you want to think about two things that would multiply to 10 but add to 7. So that would be 5 and 2, right? So to factor this, so remember, we said x times x is going to give us x squared. And then I'll have 5 and 2. So let's just see if we can double check the middle term in our head. So we've got x times x is x squared. 5 times 2 is that 10. And then I've got 5x plus 2x. So I can see then that gives me the 7x, so I'm good to go. So those are the types of checks that you want to do with yourself. Now, like I said, you might want to write them out in this level of detail at first, but try to kind of push yourself to maybe eventually get to the point where you can check at least some of these in your head. You don't have to check all of them in your head. Sometimes you're just going to have to write it out. But you can save a little time if you get some comfort with it. Okay, so now I want to just kind of throw in a couple of tricks here. So these are going to be some harder ones. So just FYI, if you feel like this is already going too fast, I will drop a link in the description to some other videos about trinomials and other ways to break this down. Like I said, this is really just kind of a quick review where I'm plowing through everything. So this problem here, this is like a one trick that can kind of come up. So notice that I've got this negative in front here. For whatever reason, having a negative in front of your squared term really kind of throws things off. So one thing I highly recommend if you ever see a negative in front of your squared term is to factor that out. So it just kind of makes it better on your brain. It's like someone looks at this and they're like, oh, I can't figure out how to factor it. And then they look at this and they say, oh yeah, I can totally factor this. And this, how will that factor? You might even want to pause the video just to figure that out. So this will factor as x minus 5 and x plus 3. So then I have negative 5x plus 3x, and there's my negative 2x, okay? Okay, so this next one, this might not look like a trinomial, but it's actually a trinomial in disguise. This is what's known as the difference of squares. So one way that you can think about this actually is you could think about this as x squared plus 0x minus 4. So it's like that middle term just dropped out. So what would that say then about the factorization if the middle term drops out? Well, the difference of squares is a really standard form for it. So it's x minus 2 and x plus 2. That would be how that factors. So a couple of things to note here. Negative 4 is a perfect square, so it's 2 times 2. So that's exactly what goes into the factorization. And so notice one of those terms has to be positive and one of them has to be negative. And that makes sense then for why we would get 0x, because we have minus 2x plus 2x. So that is kind of how that works. You can get kind of crazy with the difference of squares. So if you want to see more examples on that, I highly recommend you check out some of my other example videos. Okay, so continuing on by just showing you other tricks and things that can come up. So with E here, so I have an example of a trinomial where I have both x and y in here. So don't let the y throw you off. So you're really just throwing an extra letter in. So how would you make the x in this case? So it would still be x times x. So as far as what do you do with this y squared? So like I said, don't let it throw you off. Just think about what would multiply to 6 but add to 5. So you know that what would multiply to 6 but add to 5, that would be 2 and 3. But now you, instead of this just being 6 here, you need this to be 6y squared. So if you get x squared by doing x times x, then what do you need to add to the last terms? You just need to add a y to them. And then if you are second guessing yourself, you're not sure, once again, you can just kind of multiply everything out together. So I get x squared plus 2xy plus 3xy plus 6y squared. And yep, that gives me exactly what I need. So really it's just tacking on the y into the factorization and bada bing, bada boom, you're good to go. Now, F is probably one of the trickiest types of factoring that you can really encounter because it's got no GCF, right? So nothing will factor into this. And it's got a 2x squared here. And so this is where this whole thing of like what multiplies to this but adds to this is where this breaks down. So this is where you have to get a little more savvy with your trial and error. And some people like to use different algorithms for this. And if that's what you want to do for problems like this, I mean, more power to you. I'm going to stick to the method that I'm presenting here just because I think it's easier to remember like one set of directions than having like some whole set of steps to solve these things. So I'm just thinking about how do I make 2x squared? Well, there's only one way to make 2, right? So it's going to be just 2x and x. 2x times x is going to be 2x squared. There's no other way I can really do that. And then how do I make 3? Well, I know that's going to be 1 and 3. Now I'm going to show you the trick that kind of comes into this. So let's multiply this back out. So if we want to do it in our head, I'll do it 2 ways. So first, if we do it in our head, I've got 2x times x. So that gives me 2x squared, right? And then 1 times the 3 gives me the last term, but we want to really check if we get the middle term. So notice if I take 1x, so that's x, plus 3 times 2x, that's 6x. If I try to do the head check, I can see this doesn't work. Or if you don't like that and you want to just work it out all the way, I have 2x squared plus 6x plus x plus 3. And so now I can see this doesn't work, right? So I got 7x in the middle. And so this is really where kind of the trick with these types of problems comes in. When you have a number here, the kind of the order that you're putting numbers in matters. So instead of having the 1 and 3 where they're at, what I'm going to do is I'm going to flip-flop them. So I'm going to put the 3 here and the 1 here, and let me get rid of all this stuff down here. Okay, so now let's see if this works. So again, if we're just practicing multiplying this together in our head, 2x times x, that's 2x squared. 3 times 1 is 3. And then I've got 3x plus 2x. So I can see I have 5x, or again, if that's too fast for you, no problem. We can just multiply everything out like this. And so I get 2x squared plus 5x plus 3. So that works. So if you have something else in front of here besides a 1, it's not just x squared, these become a little bit trickier and they can take you a little bit more time, but you know, you'll develop kind of that savvy of working with them. And I have other videos where I kind of walk through this at a slower pace if you want to brush up on that. So there are other tricks, but once again, these are the high level ideas that I'm presenting here. Okay, and so finally, I want to show you guys just the sum and difference of cubes. So I think it's really clear when you have the sum and difference of cubes because it's two terms, there's a cube on them, and they're either being added or subtracted. And really, either one of these forms, they come down to these two formulas right here, which I encourage you to pause the video and write this down. So what I'm going to do is I'm going to show you two examples of just kind of how to approach these. So, okay, let's start with the first formula. I'm just adding these, okay? So I've got x cubed plus 27. So this is cubed and this is also cubed. So if you're not familiar with your list of cubes, here's just a really quick cheat sheet for you, and you can pause the video and write this down. So the way to use something like this would be to say, okay, 27 is 3 cubed. So this is its cubed form. So that might be really handy with this type of example. So really what you want to identify here if you're struggling with this is what goes in the A position and what goes in the B position. So to do that, what I want to do is I want to rewrite this as x cubed plus 3 cubed, and now I can really clearly see what goes in the A position and the B position. So in my A position, anything that has an A, I'll replace with an x, and then anything that says B, I'm going to replace it with a 3. So then this is going to be x plus 3, and then x squared minus 3x plus 3 squared. And so then if you can simplify, you should do that. So this will be x plus 3, x squared minus 3x plus 9. Okay, so let's do that one more time with a slightly harder example. So now I've got 8x cubed minus y cubed. So what I would recommend is that you pause the video here and give this a try on your own and hit play when you're ready. So going back to my list of cubes here, so I know that 8 can be rewritten as 3 cubed, but this one's a little trickier because this is 8x cubed. So I have to write this whole thing in its cubed form, okay? So this is actually going to be 2x, all of that cubed. Does that make sense? Because you'd have to cube both the 2 and the x, so you put a parentheses around it. So I've got that minus y cubed. So then I can see what goes in the A position is this 2x, and what goes in the B position is this y. So now I'm going to have 2x minus y. Now be really careful when you put this in. In the A position, it's all of 2x. All of that needs to be squared, so we have some extra work to do on that. Plus 2xy plus y squared. Okay, so then I just need to square this whole thing right here. So this will be 2x minus y. This will be 4x squared plus 2xy minus y squared. So that was a quick review of factoring. If you are realizing, oh, I forgot how this type of factoring works, or okay, I really need to see more types of these examples, no worries. This was intentionally set up to be just kind of a quick review to help you figure out where you might need more practice. So you can look in the description. If you want to see more tips and tricks, check out my example video. I have a massive example video of just factoring, all types of factoring. And also I have lots of lessons, so you can look in the description and find all of those, check those out. I go through everything in much more detail than this. This was kind of just meant to be a quick review. Okay guys, so hopefully that was helpful. Thanks a lot for watching, and I will catch you next time.